Welcome back, class. Today we're going to talk about ellipses that are not centered at 0, 0. So you're going to see a lot of the same material from our last lesson being used and introduced again, but this time we are going to be shifting where that ellipse actually is centrally located. So as you look at the two equations for the vertical ellipse and the horizontal ellipse, once again, you'll notice that they primarily look the same. Couple of key parts to these equations. It needs to say equals 1. Remember that the A value is always greater than the B value. So if the larger number falls below the Y, these are going to be graphs that are going to be kind of opening up and down, or vertical ellipses. If the larger number falls under the X, these ellipses then are going to be opening more horizontally. Then remember that the A and B values in these equations are representing distances. So the A value is the distance from the center to what we call the vertex or the vertices. The B is the distance, again, from that center point, but this time to the co-vertex. And then the C value, which is not actually in the equations themselves, tells us the distance from the center to the foci, the focal points. Remember that the focal points will always be on the major axis, which is also where the vertex points are as well. Now, the relationship between our A squared, our B, and our C is that A squared minus B squared will equal C squared. So as we look at these equations, the only thing today that we're going to be shifting and adjusting is that center point. Again, the center of the ellipse is going to be at HK. Remember that the H value is whatever is subtracted from the X, but always pay attention to, of course, where your X is. The Y value is the value that is being subtracted from, the K value is what is being subtracted from the Y value. So, like we've seen in past examples, again, here's a couple of examples of what these ellipses are going to look like. Once again, our major axis is going to be our longer axis. It's going to contain the vertices as well as the focal points or the foci. The minor axis, the shorter one, that's going to contain these co-vertices. Okay, so if we want to be able to graph a couple of equations and again identify those key points, start with determining whether the equation is going to be opening horizontally or vertically. And remember, that's going to be based on where is the larger number. Since the larger number is below the X, and again, notice the order can move around, the order can change, that's okay. If the larger number is below the X, this one is going to be opening horizontally, just like the X-axis. Okay, next thing you want to do is identify, here we said horizontal, identify that center point. So now we're looking for the number that is subtracted from X, which is 1, the number that is subtracted from Y, which is 2. So our center point is at 1, 2. And I'm going to start by plotting that center point right here. Now, my A value is the larger squared term. Remember, A is always larger than B. So if we go back to this 16, remember that this represents A squared, which means our A value is 4. And that's going to tell us the distance to the vertices. Since that larger number is below the X, we're going to go left and right 4 places. So 1, 2, 3, 4. 1, 2, 3, 4, and we can identify these points here. So our vertices that I'm going to write underneath here are going to be at, looks like 5, 2, and our second vertex point is at -3, 2. Okay, our B value is our smaller number. Again, this is going to be B squared, which means our B value is 3. That's sending us to the co-vertices. Since that's under the Y value, we know that we're going to be going up and down 3 units. So 1, 2, 3, 1, 2, 3. And that means that our co-vertices are at 1, -1, and 1, +5. And then finally, our C value, if we take our A squared minus B squared, that will give us C squared. So 16 minus 9 is 7. which means that C is the square root of 7, which is approximately square root of 7, approximately 2.6. When I am identifying my foci or my focal points, remember I'm going to be plotting these along the major axis, so that's the same as those vertices. I'm going to actually plot these in green. I'm going to be going out 2.6 places, and I'm going to be going the other direction 2.6 places and plotting these points. Now, when I name these focal points, here's where I want you to be exact. The one thing that you'll notice is both of those focal points do have the same y value of 2. So the y value is not going to change. But if you think about what the x value was, from the center, you notice that we started at an x value of 1, and then we went to the right square root 7. So that's like adding square root 7. Start with that x value of 1 and add square root 7. Then going the other direction, we started at that x value of 1, and this time we subtracted square root 7. So we'll say 1 minus root 7. And again, you want to be very exact when you are naming those focal points. Now, if you want to make sure that those points are accurate, put that 1 plus root 7 in your calculator, and you're going to see that that's about 3.6. And then if you check where you plotted the point, 1, 2, 3, looks like we're a little bit past 3, so 3.6 makes sense. Okay, don't forget to draw your ellipse by connecting your vertices and co-vertices, and we are done. Okay, when we start looking at the second example, you'll notice a few changes. Number 1, it no longer says equals 1, which I said was a key feature to the ellipse. So our first step here is going to have to be dividing by 64, and that means that we will divide everything by 64. When we do our reducing, this will become x minus 7 squared over 1 plus y plus 2 squared over 64 equals 1. Now, because the larger number, the 64, is below the y, we know that this ellipse is going to be opening vertically up and down. It's going to be a vertical ellipse. Now we can find our center point. The number that is being subtracted from x is 7. The number that is being subtracted from y is actually a negative 2. So our center is at 7, negative 2. And if we plot that point, 7, negative 2, we're looking at a center right here. Okay, very quickly, our A, B, and C values. Our A value is going to be that square root of 64, or 8. Our B value is the square root of 1, which is still 1. And our C value will do A squared minus B squared to get that C squared. So our C value is the square root of 63. And the square root of 63 can be written a couple of different ways. We could simplify it and say 3 square root 7. That would actually be an exact value. As a decimal, the square root of 63 is going to be just under 8, so approximately 7.9. Okay, now I'm going to use the simplified 3 square root c as my c value. Okay, plotting a few of these points. When we are when we're graphing our equation here, again, since the larger number is below the y, so I'm looking at this part here, that means that from that center point, I'm going to go up and down 8 places. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. These are going to be my vertices. Then I'm going to be going left and right 1 place, and that's because the 1 was below the x. So if I go left 1 place and right 1 place, these are my co-vertices. And then my focal points, since my focal points will be along that major axis, which in this one is going up and down, I'm going to have to go up and down about 7.9 places. So 1, 2, 3, 4, 5, 6, 7, 8. That focal point is going to be just inside these vertices. Okay, when we draw the ellipse, we can see that this is going to be a very skinny ellipse due to the fact that there is such a distinction between the A and B values. When I'm naming my focal points now, I always start with looking for what do they have in common. Both of these focal points are going to have the same x value of 7. So I'm not going to change that x value at all. But my y value, think about where you started. We started at a y value of -2, and then I went up, so plus 3 root 7, and then from that -2 I went down, so minus 3 root 7. So when I'm naming those focal points for my y values, I started at -2 and I went up 3 root 7, then I was back at -2 and I went down 3 root 7. And again, really look for that accuracy. Okay. Just like we were doing in our first example, I'm going to give you some key information and ask you to use that information to try to write the equation. And then with that, we're going to be graphing that equation as well. So in this one, I'm giving us a center at -2, 4. -2, 1, 2, 3, 4. I can plot my center point. Right away, I can also put my center point, my HK, into my equation. So I know my equation is going to have an x plus 2 and a y minus 4 squared. Now, the other thing, the equation we always know has to say equals 1, so we can add that in right away. Now we've got to figure out what is our A value, what is our B value, and we may even have to look at the C value depending on the information we have. So they tell us that we have a focus point at 2, 4. If we plot that focus point, +2, 4, we can see that that point is actually 4 units away from the center, which means my C value is 4. We also know that since it's going horizontally, that there's going to be a second focus point that is 1, 2, 3, 4 units on the other side. So I'm going to plot that one as well. Now it tells us then that we have one vertex that is at -7, 4. So that means -2, 3, 4, 5, 6. -7, 1, 2, 3, 4, 5, 6, 7. There's my vertex. And again, if we compare that to that center point, we can see that that is 5 units away. So my A value is 5. And that means I'm going to have a vertex on the other side of that center point that is also 5 units away. So 1, 2, 3, 4, 5. I can plot my second vertex point. Now, using this A and C value, I should also be able to get my B value. We know that A squared minus B squared equals C squared. So 25 minus B squared equals 16. -B squared equals -9, which means that B is the square root of 9, or 3. So now we have all 3 values. The B value is going to take us to our covertices. Since the vertices are horizontal, those covertices are going to have to be vertical. So from that center, I'm going to go up 1, 2, 3 and plot that covertex. And then I'm going to go down 1, 2, 3 and plot that covertex. And I have enough information now to actually draw my ellipse. So connecting my vertices and my covertices, I have a pretty decent ellipse there. As for the equation, I have to decide where does my A squared and B squared go. I know my A squared is 25. I know my B squared is 9 based on my earlier work. And since the graph is opening horizontally, we know that the larger number should be below the x value, which means that I'm going to be putting the A squared under the x and the B squared under the y. And here is my final equation. Okay, here's another example with some different information. Find the equation for the ellipse. This one has a foci at 1, 2. So we're going to plot that point, and -3, 2. Now, if these are the foci, remember that the center is going to have to be right in between them. So we can identify where the center is by finding what's right in between 1, 2 and -3, 2. And that point is going to have to be right here at I'm going to write it off to the side here. My center is going to have to be at negative 1, 2. Okay, right away, I'm going to start writing my equation. I know I'm going to have x and then plus 1 squared. I'm going to have y minus 2 squared. I know it's going to equal 1. I'm going to have to come back and fill in those fractions here in just a moment. We also know that we have one vertex that's at negative 4, 2. So let's see here. Oh, there's my vertex. And again, if you kind of look at where that vertex is from the center, we can see that that vertex is 3 units away. So if we go 3 units away the other direction, there's my other vertex. Now, a couple of things that we know here. We know the a value, which was the distance from the vertex to the center. That was 3. We know the c value, which was the distance from the focus to the center. That distance from the focus to the center was 2. And then using those values, we can again get our b value. A squared minus b squared equals c squared. So 9 minus b squared equals 4. Negative b squared equals negative 5. B squared equals 5, which means b is the square root of 5. And again, the square root of 5 is approximately 2.2. Okay? When I'm graphing my covertices from that b value, I guess I can stay blue, I'm going to have to go up and down 2.2. Again, I'm kind of estimating on the graph, but I will use exact values in my equation. And now I'm ready to actually connect those to make my ellipse. Okay, back to the equation. Again, since this one did open horizontally, we know that the larger value, the a squared, will have to be under the x, and the smaller value, the b squared, will have to be under the y. The a squared, remember, if a is 3, a squared is 9. And recall that the b squared right over here, we already knew b squared was just 5. So here's my equation. I'm going to kind of circle that. And I have my graph. Couple more quick examples. This one has, you know what, this one's actually pretty similar to one of the earlier ones we've done, so I'm going to kind of skip this one if we don't need it at the moment. But I do want to talk about this one because here we've got this very long equation that doesn't look anything like what we're used to seeing, okay? Just like we've had to do with parabolas, when we have an equation that looks very different from what we've seen before, we know we're going to have to do some rewriting. I do want to point out a couple of things. In this equation, we do have an x squared and a y squared, and those values are being added together. That's your clue that this is going to be some sort of an ellipse, because in the ellipse equation, we have x squared over, actually, let's just leave that blank. We have x squared over something plus y squared over something equals 1. So with those clues, we kind of, excuse me, we kind of know we're looking at an ellipse here. But the problem is it is nowhere near the right form. So we're going to do a little bit of grouping here. We're going to group our 25x squared plus 150x, and then we're going to leave a blank. We're going to group our 4y squared and our 16y, and again, we're going to leave a blank. And then we're going to bring that constant to the other side, negative 91. Okay, now, what are we going to do in here? In here, what I would like to do is a little bit of factoring first. In this one, I'm actually going to factor the 25 out of the equation. So that's going to leave me with x squared plus 6x plus blank. And over here, I'm going to factor the 4 out. That leaves me with y squared plus 4y plus blank equals negative 91. Then inside here, I'm going to be making a perfect square trinomial. So I'm going to be taking my b value, dividing it by 2 and squaring it. That's going to be a 9. And then remember that I'm going to have to add a corresponding term to the other side. But technically, this 9 is actually being multiplied by the 25. So I'm actually going to be adding 225 to the other side. Then I'm going to have to do the same thing with the y's. I'm going to take that b value, divide it by 2, and square it. That's going to be 4. Since that's technically being multiplied by this one, I'm actually going to add 16 to the other side. So now on the on the left-hand side, I have 25. I can factor this. Over here, I have 4, and I can factor this. And on the right-hand side, I have negative 91 plus 225 plus 16, which is going to give me 150. Now, part of the problem here is that I still want this to say equals 1. So the next thing I have to do is actually divide by 150 across the whole equation in order for it to say equals 1. Now, when I do that division, I'm going to do a little reducing. 25 goes into 150 6 times, so this will become x plus 3 squared over 6. The 4 goes into 150, not evenly. The 4 goes into 150 37.5 times, so this is going to reduce to that. And now I have an equation where I can try to find my key information, my center, and a lot of that other key information. So as we look at, this equation here, one thing that you do want to be looking for is your center point. My center point is going to be at negative 3, negative 2, based on the values that are being subtracted from x and subtracted from y. To find my vertices, my co-vertices, and my focal points, I'm going to need to know my A, B, and my C values. Well, my A value, remember, that's going to be the larger one. So this is representing A squared. This is representing B squared. My A value then is the square root of 37.5. My B value is the square root of 6. And for my C value, if I do my A squared minus B squared, that will give me my C value. So C squared equals 31.5, which means my C is the square root of 31.5. And I'm going to leave these as radicals for the time being. When I go to actually plot these points and graph them, I'll use some decimals to help me with doing that. Plotting my center point should be fairly easy. We'll plot my center point at negative 3, negative 2. Since the larger value was below the y, we know that this is going to actually be an ellipse that is vertical, going up and down. So my vertices, I'm going to go up square root of 37.5 and down square root of 37.5. And the square root of 37.5 is approximately 6. So I'm going to go up 1, 2, 3, 4, 5, 6, plot that vertex. Down 1, 2, 3, 4, 5, 6, plot that vertex. Okay, when I'm naming my vertices, notice that both vertices have the same x value, negative 3. Okay, but the y values are changing. So again, look at where you're starting from. We were at a y value of negative 2, and then we added or went up 37.5. So I'll write negative 2 plus square root 37.5. And then I went down square root of 37.5. So negative 2 minus square root of 37.5. Okay, these are going to get a little bit trickier when you don't get the pretty numbers, the nice numbers, but they are still graphable. Okay, my co-vertices, I'm going to be going left and right, the square root of 6, and the square root of 6 is approximately 2.4, so I'm going to go 1, 2, and 1, 2, and I'm going to plot those points. When you're naming these ordered pairs, notice that these 2 points are going to have the same y value, so these are both going to have a y value of negative 2. So then you have to look at that x value. The x value here was at negative 3. I was at negative 3 and I added root 6. Then I was at negative 3 and I subtracted root 6. For my focal points, remember the focal points will be going up and down just like the vertices. So for my focal points, I'm going to be going up and down about square root 31.5, which is about 5.6. So I'll go up 1, 2, 3, 4, 5.6 and down 1, 2, 3, 4, 5.6. And those are my focal points. And again, when I'm naming my focal points, you'll notice that just like the vertices, the focal points are going to have the same x value, -3, that won't change. But we were at a y value of -2, and then we went up the square root 31.5, and then we were at -2, and we went down the square root of 31.5. So these get a little bit messier, still graphable. Just pay attention to that center point when you are moving up, down, left, and right to really name and identify those vertices and focal points and things like that. Okay. The last one here is to write the equation of the following graph. So a couple of things that I want you to notice here is right away we can see that center point. So if we plug that in, x plus 5 squared, y minus 4 squared, and we know that it's going to be equals 1. And then we can look for our distances. The distance to our vertices, we went from -5, and this vertex is at -1, so that's a distance of 4. That means our a value is 4, which means our a squared is 16. Since this is opening left or right, that 16 needs to be below the x. Then we can go back and look for our b value. Our center was here at 4, and then our co-vertex is up here at 6. So that means our b value is 2, making the b squared value 4, and that one will have to go underneath the y. And so very quickly we can write an equation of the graph by looking for those key pieces of information. Tonight, try some of these problems using the My Math Lab, and don't forget to message me if you have questions.